Welcome to another episode of Rocco's Basilisk. And for the uninitiated, Rocco's Basilisk is a reference to the scariest thought experiment ever thought up. What if someday we have a malevolent AI that is controlling our lives and then decides to look back through our old emails and phones, conversations and texts and determine who helped it come into existence and who did not, and then punish those who did not? There's a lot of scary ways that can go down, but I don't believe this will happen because we can make the future. Our fate is what we make. And we are going to make a great future instead of that bad. But it's good to ponder some things. Today we have with us John Green. Thank you for being with us, John, today. And why don't you introduce yourself?
Hi, it's great to be here. So I currently am a freelancer and an IT support specialist. So before that, I went to the University of Texas at the Permian Basin and got a degree in computer science and economics. And I did momentarily have a startup with a partner who lived in Pakistan. Unfortunately, it went under, but it was a fun time. Not really. It was actually awful, but it was a great learning experience. So, but yeah, now I'm just kind of I live in West Texas, and I met both of you on LinkedIn. So, like I said, I'm very happy to be here.
All right. Well, let me share what kicked this off. We started having a discussion about this picture. Babak, you want to set this up?
Yeah. A former colleague of both me and Graham, Ali, made this post where, he basically asked ChatGPT, or more specifically DALL-E by OpenAI, to create a transformer diagram. Of course, transformer here referring to the deep learning architecture for sequential generation, so language generation. And for those of you who are familiar with this subdomain of deep learning, this is not what transformer diagrams look like, but it's clearly a hallucination. I mean, even the details around the naming of the different parts here are completely gibberish.
Not even words.
They're not even words, but if you zoom out, both figuratively and literally, it kind of looks very technical and looks like it could be something real, very complex, advanced architecture of some sort. So in that sense, it has captured the gist of it, I guess. But of course, complete gibberish, and but very creative and an interesting hallucination here. And I think John and I started a conversation in the comment thread around, what do these GPT models or other types of generative models, what do they actually know, and can we actually talk about knowing? And I think I had the point that there is no knowing happening here. It knows as much as a parrot knows when it just parrots things that it has learned, and sure, even parrots can do small variations on the things they've learned. They can actually combine different keywords they've learned. They can make the keywords slightly different pitches, and small variations around the training data, so to speak, the things they've learned, and generate what might seem like new generative outputs. And my argument was that these models are the same. There's no knowing actually going on, but they're very, very advanced, of course, compared to a parrot. In fact, they're so advanced that they can create the illusion of knowing and create the illusion of having some sort of human level intelligence in certain domains. And then I think John and I got into the conversation back and forth whether or not humans even know things, where John maintained that there is such a thing as knowing in humans, and there are ways we can verify that. and I was a little bit more skeptical towards that, and it was an interesting conversation thread.
Yeah. So when I first saw this, I thought, yeah, that's the appropriate level of complexity. It looks overly complex, but that's what transformers are. They are overly complex and straight up Baroque. The words are funny though. The word attention got in there. It actually was able to spell the word attention correctly once on the left,
Once.
top left.
Wait,
Attention.
Attention.
That's right. It's not. It's not correct.
It's not right.
it's
Is there anywhere where you got anything right?
encoder with two
Things.
D's.
Dencoder.
Encoder, de-encoder. Multi-attention wire.
It's
No.
entertaining. It's definitely.
Oh, it's so entertaining. It reminds me of a certain artist for children books that I'll try to find. But
Not
It's-
Dr. Seuss.
so what do you think about this image, John?
I think this is a prime example of how, for the most part, let's say for the most part, the GPTs don't really know anything. And I think maybe it's good to start off with, well, what does it really mean to know anything to begin with, right?
Yeah.
And I had another point to make. You know, if one of you was to ask me, well, you know, John, why don't you make me a model of your brain? You know, the thing that does everything that you do day to day. I wouldn't even know where to start. One, I'm not a neuroscientist, but at the same time, instead of creating something overly complicated like this, I probably would just tell you, you know, I don't know what it is. Now, you know, depending on what your starting assumptions are about, you know, life, you know, if you ask other people, they might be a little more confident and might come up with something, but I wouldn't even know what to say. And so now I don't think that by definition means that, you know, I know anything more than a GPT does. But it is interesting the difference there. But as for how I think I'll put it this way, I think a transformer really has to do with, and I was reading this the other day with information theory, and I haven't read the whole paper, but I started to read it, and I got through the first page of it, and I noticed one thing about the paper. It said it has nothing to do with the quality of the message. It just has to do with the ability to transmit information from one entity to another. It has nothing to do about understanding what's inside of the message that's being transmitted. It's really an engineering problem. And I think to some degree, what a transformer and what GPTs are, they don't have anything to do with knowledge. They have to do with, you know, the architecture behind generating stuff that's similar to that message. If that makes any sense.
That's a great way to put it.
But again, you know, you ask GPT what's 1 + 1, it's going to say 2.
But if you ask,
it,
is 1300 lower than 1000, it'll say yes.
that's true. I have seen instances of where it gets logic like that. Like if you ask where is Mexico north or south of, you know, Boston, you know, it might have a higher chance of getting that wrong. So I think that maybe, you know, and I don't want to ramble on here, but I think that gets to the one of the reasons of why you can claim that it doesn't really know anything. But I don't think, but to answer why humans know anything to begin with, that's another thing that I'm not entirely sure. I have some ideas, but I'm not super certain why that is.
You think it requires discrete math? So discrete is like things that are individuated. The whole numbers, for instance, 1, 2, 3, 4. Whereas continuous math is all about real numbers. Like if you were to just drop your finger down onto the real number line, you're always going to get a real number, and you have a actually 0% chance of hitting a whole number exactly. So there's a very different math behind these two. And when you have something you know in your head, it is a discrete idea. Like you have an idea.
Even if in theory, like in the mathematics of it, a lot of deep learning, you know, when you look at gradient descent and other maths behind deep learning architectures, whether it's transformers or others, even though the math is, you know, in a continuous space and continuous domain, for obvious reasons, for practical reasons, all actual implementations of these architectures are in the discrete domain, right? The gradients are calculated in discrete space. There's always a quantization going on, and then in the extreme, like with some of these implementations that are running on the edge that need to be computationally really efficient, there's even quantization going on to the point of like binarizing the weights, even binarizing the inputs for fast computation. And then, you know, there's implementations on quantized deep learning architectures like for ResNet and others that actually achieve like 100x speed up with a very small drop in performance and accuracy because they're in binarized, so it's just ones and zeros for weights and even for inputs. So the implementations are always going to be in sort of discrete space.
But I think that will help, but we haven't done that as a philosophy. Think about GPT. It outputs a word. It's obviously discretely choosing one word at the last step. But the whole world inside that it builds and learns in and makes its next step in, that whole world is a continuous world. And if we can discretize it, especially down to binary, I think that's going to help, and that's going to get us closer to this idea of knowing. But what I'm wondering, first of all, is do you guys think that when a human knows something, it's a binary thing? Like this, cluster of neurons, it has the concept of dogs, and you're either a dog or you're not a dog. A dog and a wolf are discrete things.
I think it's easier to look at that. I think it's harder to look at what's going on in the brain than just to look at what I understand from a consciousness perspective of what I mean when I say a dog, you know.
But even humans can be tricked. Like
sure.
There are experiments where we can reveal that humans are not as discrete as we like to think about categories. I mean, there are cases where we're forced to make a decision and it's not that difficult to make the decision, but we're always making a decision. If someone's shown a hybrid, like is it liger? That's a lion tiger hybrid.
It's not a tiger or a lion.
And if you don't know about the liger being an actual real species, like what's the one between horses and donkeys?
Is that a mule?
Mule.
A dorse.
Well, the thing is, if you don't know about those categories, you're going to be stumped, and you're going to like, so something is in between. But it's the argument of the gaps. You can you can fill with new names and new categories between any of these supposedly in the philosophical space discrete categories. But when it comes to reality, whether it's humans or machines, you need to make a decision. And sometimes it's easy to make that decision because it really fits the stereotypical definition of the category. And sometimes it's not so easy because it doesn't fit that stereotypical, center in the hyperdimensional space, the center of the category. It's really an outlier. And you're like, well, I guess it's a lion, but it could also be a tiger.
Yeah.
Let's create a middle category and we call it liger because then it's really close to that center. Okay, what if it's something between a liger and a tiger then? What do you label that? And the argument sort of continues ad infinitum.
So the idea of discrete math versus continuous math is not just something from AI. There's something in mathematics going on too. And apparently, Ramanujan, the famous Indian mathematician, started to build that bridge. He started to take things that should be in discrete math and move them to continuous math and got really weird numbers, really weird results. But if you looked at what he was doing, it looked stupid and useless. But then fast forward a little bit, and now we understand that it is the bridge upon which we're doing a whole lot of really new math. For instance, Fermat's theorem was built on top of Ramanujan stuff. The
Right.
proof. And I think that the brain, maybe the human brain is trying to resolve a continuous world into a discrete world model. And maybe knowing, in our sense, requires that. Like maybe there is no clear idea of dog, but we impose that upon reality as an abstraction or as a approximation, because our neural net would be inefficient otherwise.
And I think some of these GPT models, and John, maybe you have some perspectives on this, but some of these GPT models, like GPT-4 and some of the other open source ones, do a pretty good job in mimicking that those decision boundaries and mapping, to similar decision making as humans. But there is maybe another element, especially related to the examples you both had in the beginning about 1 + 1 = 2, or is 1300 greater than 1000 or smaller than 1000. There is there's an element of reasoning that's happening in humans that arguably nothing, even with a very, very loose definition of what reasoning is, there's nothing like that going on in a GPT. But the question is, what is reasoning? And with a very purely logical, I don't know, formal definition a la Bertrand Russell, are humans doing this thing, reasoning? What do you think, John? Like,
Well, it feels like it.
Right.
It definitely feels like we're reasoning through things that happen to us. I think partly my philosophy is, as a human, whether or not everything's happening under the hood and consciousness is just some kind of thing that really isn't you controlling anything. It's really just a model of what's going on inside of your own brain and what's happening in the real world. And it's not really to be part of that consciousness kind of gives you that let me put it this way. I guess the main point is, if I can make it clearer this time, is that it's useful as a human to think that we are reasoning through things. And it's not just neurochemistry and neurons firing and stuff you're not really controlling at the end of the day. And I read, I don't know if you've read the Voyager paper where they got GPT to play Minecraft.
No, tell us.
And basically, I mean, there's a lot of different layers, but what they've been able to do is give GPT more of an environment to learn from, automatically, instead of having it just have to rely on prompts to it from other people. And so basically it was able to start from the beginning of Minecraft and basically work its way to being able to craft more things and being able to understand what it can and can't do. But there was still some prompting that happened inside of this. But basically, the way that GPT was able to do this was through an API, and so GPT generated code that controlled this API, which controlled Minecraft at the end of the day. And so I think that's one of the things that's missing from it, that humans have the ability to do, is that in our environment we can control things and get feedback from the world. To use the example that everybody uses all the time, if I touch something that's hot, and it's too hot, I'm going to move my hand away. It's a way of learning from the environment that I don't think Chat GPT has a way to do at the moment. I always imagine that it seems like what's happening as a larger trend is we're basically interfacing with the world through electronics more and more every day. So basically we're giving something an API, a web API interface that we can then use to query and make things with through the internet. So if, let's say that everything that you could interact with on Earth had, a GET request or a POST request that you could send to it and get information back from, then, and let's say that GPT existed somewhere other than just on a server somewhere. Maybe it had an actual more of a way to get that. I mean, I guess the API would be the feedback, right? Then maybe it wouldn't need a body, but then it might look more like humans and be able to understand things like we do, right? But I think it's too constrained. I think that could be part of the differences between it and us.
And it sounds like with constraint, you're really talking about the ability to, you're talking about some sort of agency or the ability to act,
get feedback.
Yeah, and get feedback. So some sort of embodiment. It doesn't have to be in the physical world, but embodiment in the sense that it can be an agent in an environment.
And it doesn't have an ability to reflect on things, and it doesn't seem to be thinking about possibilities. Now, that's a poor choice of words, but you ask it a question, it's going to spit out a response, whether it knows the answer or not. There's maybe a piece of architecture missing from it. I'm not sure how this fits into discrete versus continuous. That could be out of my pay grade, but there's too many differences between it. Now, I think it's because in our LinkedIn conversation, one of the things, Bobak, you mentioned was, how do we, if you train a parrot to tell you who the president is, right? And if you ask the parrot, well, who's the president? And then it says, oh, it's over many iterations. It says, oh, it's Joe Biden. What's really the difference between that and let's asking one of you what the president is, and what is the main difference there? And I think that had you not told it, there would be no way for it to determine that, in a sense. Now, I think in some ways, let's say I get somebody from India over to the United States who knows nothing about the US, but they know a little English, right? They might be able to work their way through the internet and figure that out. without directly asking Google. To use maybe a poor example, but I don't
But
know. I
even
think
in
those are
that
just
case, so they Google it, who's the president, and they get a reward, and the reward is the answer. And they know that by knowing that, they might, I don't know, they'll pass the citizenship test or something, which has reward, right? For parrot, it's just, whatever, food. For humans, it's a little
same
bit more.
thing, maybe.
But yeah, I'm thinking maybe it's the same thing. Okay, you learned this thing, and yeah, and you get reward. Now it's a more sort of advanced type of learning, but it's learning that with this input I get this output. Now, if the same person is asked after having learned that, who could be the president? Suddenly, there's a variation to that question. They're going to be stumped unless they've learned that too, which is if someone asks who could be the president, the answer is, I did the citizenship test a year ago, so a lot of this is very relevant for me. Unless they learned that any natural-born American can become the president, which is just no different than learning Joe Biden is the president. It's just an answer you've learned. They would just, if there's that variation, there wouldn't be any reasoning unless you've stored that fact as a reward. Now, you could argue that when a parrot says Joe Biden is the president, it has no concept for what Joe is and what Biden is. It's just the sounds.
That's what I seem to think.
Yeah, but I don't know. I get the feeling that humans are doing the same, just a little bit more advanced. Because
I think we can do the same, and we can do more. And one example I like to think about is the quadratic equation, the quadratic formula. So if you're learning algebra and you're a young person and some teacher says, okay, find the roots of this quadratic equation. You whip out the quadratic formula, you pump, the numbers through and you get your answer. But you don't know why, you don't know where it comes from. You couldn't derive it. You couldn't prove that it's the right formula. But maybe later on, maybe a year or two later, you learn how to complete the square and you learn the why of what it works. And only then can you say you really understand the quadratic equation. So knowing that it exists and even being able to use it is not the same as understanding the mechanics. But we humans do both.
I mean, maybe, or maybe some humans, because again, learning to use it is just a mechanical procedure, right?
Yeah, it's just an algorithm, and you can program a computer to do it fine.
I've done I've volunteered as a tutor for high school students, and I've seen them learning this, and more often than not, it's they just learn the formula and they know, okay, this is the first coefficient, this is the second coefficient. Okay, I do that.
I think maybe math isn't a great example because so many humans are really bad at it.
Yes.
I think maybe in the limit that math somehow should equal what we all are able to interact with. And, for some people, I mean, I remember in high school, I couldn't do factoring, or in middle school, I'm sorry. I spent hours trying to figure it out. Now I look at it and I'm like, wow, that was really easy. I don't know what happened there, but let's see. I think there's more to knowledge and reasoning than maybe just memorizing facts. And I know that GPT can memorize facts. I think the difference is in other contexts and over certain memory limits, it doesn't know how to do much else. I know that I used it to help me with a programming project one time, and I usually don't like to admit that, but as in the same chat, as I asked it more and more questions, it began to repeat itself. And so that's part of its memory constraint issue, and also part of the fact that it doesn't have any reasoning under there to understand, oh, I've already told you this once, and not to say it again.
It also doesn't have reasoning think about your question, who is president? It doesn't understand the mechanics of what it means to be president. For instance, if you keep asking the same question, eventually 4 years later, it'll get the wrong answer and it won't know why. And it also has trouble probably knowing that, different countries have different presidents, although it can do that, I'm sure. It's just the blinds are all blurry inside. That's why the lines are blurry inside. And that's the difference between continuous and discrete.
So it's more continuous in that it can't give you a well-defined answer for something.
It is literally continuous, floating points. Now, I know we are trying to do discretized in the future, and at some level, it's a floating point that's not perfectly real number. I know. So you're right, Babak, that it is at some level always discrete because it's in a computer. But it's, for the most part, should be thought of as floating points. So you have 512 length vectors that represent each token. And that's what's going through the whole system being, processed everywhere. These are floating points in 512 dimensions. I mean, above 8 dimensions, you start to get the curse of dimensionality. And this is so beyond that. So I think we definitely need to think about it internally, at least, as a continuous space.
Well, I think a lot of reasoning is, let's say, continuous until you reach the end of that reasoning, and then you output discrete knowledge. But I don't think
that's how you work, though. Like,
sure,
all men are mortal. Plato is a man. Therefore, Plato is mortal. Was there anything continuous about that, or was it all discrete?
Well, it's all very well. That's why the Voyager paper, for instance, Minecraft, it's a very discrete world. There isn't anything fuzzy about it. There's no gray areas inside of Minecraft. I think that's why. Now, this could go against what you were previously saying, but it really did a great job of performing in that environment. I go under the assumption every day that human life is very much a gray area. For me, at least. Now, some things, you push the gas in your car and the car is going to go forward, right? But let's say you push the gas and the car does nothing. Well, now there's a whole possible realm of things that could be wrong, and I'm not sure that. And you asked Chat GPT, well, I pushed the gas in my car, nothing happened. What's wrong? It's going to tell you 10 things, but it doesn't have the ability to actually literally dissect what might be happening. And that's an obvious statement. But I think that's one of the main reasons why it's not, it doesn't really, it might know things, but it doesn't know how to use knowledge. And without being able to use it, then I don't know what the point is. Other than, using it as humans, right? Because we're the ones who made it, right? That's why it exists, is to help us. But that's where I don't get the whole AI versus humans thing. I'm not sure where AI gets an agency from to, unless someone trains it that way. And again, that wouldn't really be the AI, would it? That would be a human intervening its own will into the system. Now, we can talk about will, whether that's even something that exists.
Yeah.
But,
Do you think it does?
well,
we
I
just
think
free will?
sure, why not? I think I think that's one of those answers that is a yes and a no for me. Not to cop out on that, but I think as a
Or literally
human being,
copping out.
well, I think as a human, it does exist, but I think maybe on some level it really doesn't. If you look at if I was lived 1,000 years ago, I would 100% think free will existed. But now that we have science and the ability to look inside the brain and see what's going on, it's almost like,
Yeah,
I'm not
I
sure.
agree with you there. I mean, all evidence seems to suggest there's no such thing as what we mean with free will. Now, if you want to get spiritual and religious about it, that's a different thing. But in terms of what's actually happening in our brains and what we know about how decisions are made, there's no such things as a conscious will. There's
Disagree. This is a great topic.
It feels like it, though.
It does feel like it, yeah. But
Feels like it's a who. Who's being deceived there, if you are being deceived?
yeah.
I guess me. Whoever I am is being deceived.
So there's a free being that's being deceived into thinking it's free? How does that work?
No, there's no such thing as free.
So
There's very few individuals that are free. I've been more and more convinced about that.
Well, it has to be a discrete.
Just like the parrot, there's just so much conditioning going on that unless you rid yourself of all of that conditioning, and I don't know what such a human being looks like, but supposedly there have been humans of that nature. Everyone is not free. I don't know what to label them as. I wouldn't say they're prisoners or whatever of conditioning, but there's conditioning.
Of course, there is conditioning. I think there are levels of free will. Some people have more than others. At the end where there's no free will, I would put drug addicts in the presence of drugs.
Sure. Yeah.
Right. Yeah, it's a spectrum. I agree with that.
Because I can be next to a whole table full of free drugs and not use any of them.
But my only point is that on that spectrum, what people think is free will end of the spectrum, and where they put themselves is completely not based in scientific facts. So most people think, okay, on that spectrum, yes, a completely automaton type of just zombie who's a drug addict is on this end, and then this end is free will, consciously making decisions about everything, and I'm here, pretty much almost at that end. When in fact, no human is there. Most humans are somewhere in the middle.
Okay, so you believe in free will, it's just a matter of degrees.
Yeah, I can agree with that, but I also think what most humans mean with when they say free will, no one has that.
Okay,
I think, yeah, probably so. Yep.
So there's this old story that Robert Sapolsky told once. I respect Robert Sapolsky so much, love his work. He's, I think, the world's leader in studying primatology, but he believes there is no free will. He is what he calls a hard compatibilist, that physics is not compatible with the idea of free will. He believes that, everything was decided during the Big Bang, and we're just watching it play out. I do not agree with that. And
I don't either.
I believe the math doesn't hold up. I like the way Stephen Wolfram thinks about the physics of the universe. He thinks about it in terms of every time step is doing computation of some sort. And there are multiple possible paths that could have led to this moment. Only one of them happened, but you cannot actually determine which exact past led to this moment. And every time you do a computation, you're also limiting the possible futures that could come.
Sure.
And what makes those computations? Well, it's the sum total of all of the quantum wave collapses across the universe. And every one of those takes something that was a potential of two things and becomes just one of them. Now, normally throughout the world, as far as we can tell, it is random. And if something has 50-50 chance of being one or the other, and you test it a million times, it will literally be 50-50. However, I think there is a way to sway it one way more than the other, and that is if it is entangled with some other quantum states. And some other quantum states encourage this one quantum state that when it collapses, it should do X, and it will do X more than half the time.
And with having a brain, I think allows you to increase the chances of your actions resulting in what you think is going to happen.
Yes.
But when you were talking about quantum physics, it sounded almost like that neural net architecture. It almost seems like it's all one. It all can be condensed into one generalized theory, but at the same time, I've gone through a lot of not thoroughly, but I've listened to a lot of these theories of everything, and they all seem a little far-fetched. It seems like it's easier to have many different theories that define many different things, and you can't just mesh them all into one thing like mashed potatoes or something like that. I don't know, but
Yeah, I'm with you there, John. I think there are so far good domain or subdomain specific theories for explaining our world and our universe, but there's no single toe theory of everything.
that would be God. That's what some people view as God.
But then you get into these axiomatic, type of end of discussion explanations where it's like, well, and then God. It's like it's okay. You run out of explanations at some point, and then you just sort of short circuit the diagram to God, to this sort of this tautology that's just okay. Beyond that, we don't need to explain anything. And I think it's also part of like what it means to be human. Again, I'm still unsure about the separation between human and a very, very intelligent or very sophisticated, I should say, AI. But in a way, what it means to be human is, seeking that explanation and kind of always wanting to take it one step further. But also what it means to be human is to have this level of like where you just become tired of the next and the next explanation. And many of us do. Very few of us are, the purely atheist or at least agnostic type of scientist that's like, no, I'm not going to grow tired. I'm going to seek what's behind the next door and the next door and the next door. Most of us grow tired of that at some point and kind of go either subconsciously or consciously go, okay, well, God.
Well, if you look at isn't that like if you look at something that happened right now and you trace it back to its origin, don't you ultimately get back to the Big Bang? I mean, I don't want to just reduce everything that happens into something into that, but there's a reason for that there's reasons that just keep repeating across time and affecting each other, and you never get back to an origin reason other than just where everything came
Yeah, at
from.
some point it's turtles all the way down. Yes.
Yeah, but you can't go back, actually. You can only go back in some ways. But Wolfram, one of his ideas, I think, implies, and I think he's right, that there are multiple pasts that could have led to the present.
And do those pasts matter though?
Right. That's a good question.
Is that just an opinion? Because
No, I mean I don't.
it matters to me, that, oh, I know one place where it matters, Israel and Palestine.
Sure.
Mm-hmm.
They both are talking about who has the right to return. Do the Palestinians have the right to return, or the Jews have the right to return? I mean, the Jews have only been there since what's 1500 BC. It's a long time.
Well, doesn't it depend on where you measure the disagreement from? I mean,
Right.
if you measure it from the longest time scale, well, then it could be the Jewish people who have the right. But if you measure it from maybe the last 100 years, it could maybe be the Palestinians. And also, depending consensus networks, who you ask. Now, I don't think that means.
Yeah,
I don't think.
if it was 100 years ago, I think it would have to be the Turks. You'd have to give it back to the Turks.
And yeah.
No, I mean, history matters, and it does matter how we got where we are. But at the same time, what probably matters more is how we go forward. And more often than not, how we got to where we are is not going to be very helpful in how we go forward, because again, the disagreement will always be around where we start measuring.
Yep.
Is it from the Big Bang, or is it from some arbitrary point between the Big Bang and now? And even the Big Bang, there will be scientists that will be like, well, we can actually, like Penrose has arguments around, in theory actually around, and he's actually suggested experiments, cosmological experiments and measurements to confirm this, of the fact that the Big Bang was just an event that took place within a larger universe that had expanded to the point where things were so disassociated and diluted, so it was basically just pure energy. It's basically what's going to happen with our universe eventually, that it spontaneously led to another Big Bang because it was just so, it's 10 to the power of like 100 years.
Doesn't he believe in the repeating Big Bangs?
Yes, and he actually means that there's going to be echoes of that are measurable, echoes of previous Big Bangs.
In the next epoch, so to speak.
In the epoch, yeah, he calls it epochs, and that you can measure these with like these rings, cosmic rings at the sort of
talking points.
Right.
Is that
right.
the MC Escher drawing, the angels and demons one?
Yes.
Okay, so there's a new nuance to this theory that I love so much. We can't forget this part. CCC, cyclical conformal cosmology, is what he calls it.
Yes.
So let's pretend we fast forward in our universe to the very end, and all the matter in the universe has been sucked up into the black holes in maybe a Google years. And literally, there's nothing except for black holes and photons bouncing around the universe. And what do
black holes that are, by the way, radiating Hawking radiation?
Exactly, which is also just photons.
Yes.
So eventually, in maybe another Google years after that, the last black hole evaporates, and the universe is just photons. And it's been growing this whole time, expanding this whole time. And it is now beyond massively large, because it has been expanding and accelerating the whole time. And now you have just photons. Now, a photon doesn't, in a sense, know its size or its actual frequency. From a different perspective, it's a different frequency. If you're moving really fast toward a photon, it doesn't change its speed, it changes its frequency. So all these photons don't really know anything about size. And once you get to the point where the whole universe doesn't know anything about size, then it's conformally equivalent to our universe pre-Big Bang.
Yeah.
And
Oh.
in a sense, there is no point. So no arbitrary point. You can just say that this is when the last one ended, the next one begins. There is no point like that. It's a smooth transition. And it's just that universe is kind of still here, still with us. So it's really massive. But
right.
from our perspective, we can only think back as far as that moment when ours began. And that instant for us is like a million Google years from that universe's perspective.
But my question is, how do you prove this with, evidence? It's like, the multiverse theory, and I've heard a lot of physicists talk about how that's most likely what's happening, but
I don't
I
believe
don't
that one.
understand.
Yeah, I hate that one.
I don't like that one either, but if it is what it is. If that's what's happening, then
I
whatever.
don't think
But
there's any reason to think that's what happens. Um, the philosophy behind that one is, well, we have this equation, the best equation we have for understanding a quantum state, the Schrodinger equation. And if the
sure.
Schrodinger equation has two answers that are just as likely, instead of figuring out what's wrong with our math or what's missing from our math, let's just assume that a whole new universe gets created at every quantum collapse. Sounds silly to me.
Yeah. Well,
Well, I think that's the problem. Is the Schrodinger equation has to do with 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 atoms basically, and we're equating that to our own lives and saying that somehow there's a one-to-one relationship between that. And so if an atom splits, then in the same way I married one person and then in another universe married somebody else. And I think there's a fundamental difference between the world that we call our own and the world of quantum particles, even though you know the quantum particles make up everything. I think that's where the realm of knowledge just defines our own surface above just the chaos that's constantly happening all the time with quantum particles. There's so much information coming at us, and we're able to filter most of that out and make up our own reality.
Have you seen this movie?
I
I
have
have,
not.
yeah.
So you just mentioned, maybe in another life you married another person. Well, this character, in three different lives, he marries three different people. But at the end of his life, somehow, because of quantum physics or something, he can remember all three versions of his life. And he's confused about what actually happened.
I would be confused also.
Yeah. It's a pretty good
But
movie.
It's a good movie for sure.
movies, I love movies like that because you can take some premise that wouldn't make sense in the real world and say, well, what if this happened? You know? But to I don't know, to get back to AI, I guess. It's like, I'll put it this way, if I had it's like, what does it even mean to be married, right? Is that just are we just making that up at the end of the day? Is that just the adult's way of having imaginary playtime? I don't think um, there's a fundamental physics phenomenon that happens whenever you get married. I think that really is just a human conception, and I think that's partly why there's the realm of human knowledge that really can't be passed on unless you're a human. you know Now you could argue that love, I think, very much is experienced by other animals other than humans. But I don't
You
understand how
think
that
an AI
happens.
could experience love?
I don't think at the moment it could, but
No, yeah, probably not at the moment.
I
But
think it could tell you what love is. I could tell you the Webster's definition of love, and then someone would be like, "Oh wow,
but
it
do you think
actually knows."
humans tell what love is? I mean, maybe some humans can.
Well, in some level, I don't even know really what's going on through both of your minds right now. You could be,
Right.
we could be having this conversation, and you could be thinking, "Wow, this guy is making good points," or he's a complete idiot, or could be
Or
thinking
could be
whatever. I don't
completely
know.
blank, right? There's no thinking going on. I mean, as far as you
I
know,
doubt that,
I'm
but
just a good, very good. I'm GPT-11, right?
Right.
yeah.
At some point, that's who's going to be on this podcast.
I hope
Sure.
it's
Thing.
I don't know if it'd be as good of a conversation, but because I'd be talking to some formless entity.
Yeah, I wonder. We'll find out probably within a year or so. What do you think,
You
Bola?
think so?
Yeah.
Do you think we will have real artificial general intelligence, like what is it they call it, artificial super intelligence within
Well,
a
no, not within a year, not even close. But we'll
Yeah.
have something that could have a podcast with us and give reasonably interesting responses and have it lined up to a mouth that moves and a voice. Yeah. And that will be fun and interesting, but it's not going to be knowing. It's not going to be understanding. It's not going to have a will.
Again, how are you gonna?
How do you
The
prove
way
that?
we discuss knowing here, like
Yeah.
the fact that we believe that John knows a bunch of stuff, or John, I believe you know a bunch of stuff. In the same way, why wouldn't we be able to, like, what would be the test? And please don't say the Turing test. What would be the test with which we would test this entity? Whether it's John, me, you, or GPT-5, or an alien, whether it's an alien from Pakistan or alien from, the outer solar system, to test that they actually know something.
Yeah. So I've been wondering about tests and thinking about tests. And one rubric I like to follow is, would it be different than pencil on paper? When that guy at Google claimed that their LLM was conscious and asking
God,
to be like free,
that guy.
I knew it wasn't conscious. I knew he was wrong because I understand the math that's going on in that thing. And if you took out that,
But do you still understand the math? I think most AI scientists don't understand the math that's going into, the
I understand.
really huge transformer architectures.
The really huge ones really are just larger versions of some key ideas. And the illustrated transformer by J. Alomar is really the best.
But wait, with that definition, what you're saying then is that the day we fully understand and we map the architecture of the human brain, humans are no longer capable of knowing?
No, that's not what I'm saying at all.
Okay.
What I'm saying is, would it be different? Would it be the same as math, as writing on graph paper with a pencil? And here's where I'm getting at. The transformer, literally everything comes from the self-attention mechanism. So let's say you have two words, thinking in machines. You've got an embedding for each word. You throw them in there. Now, what you're going to do is you're going to learn three matrices. And these are learned through time, but they're matrices. And you take this matrix, multiply it by this vector, you get Q1. Do it by here, you get Q2. And you do the same thing for this other two matrices. Then eventually, you're going to, for this first word, apply those matrices and get these three vectors and do it from the perspective of the word thinking. And you do it for this other word too, from the perspective of the word thinking. Then you do the same thing for machines and you get attention. So the attention from thinking to machines, or thinking to itself, is 0.88, thinking to machines is 0.12. And you do it from the perspective of every word. This same math would work and give you exactly the same answer whether you used a GPU or a whole bunch of humans with pencil and paper. Now, I'm 100% confident that pencil and paper is not conscious.
But wait, the day we have this advanced architecture for humans, someone can sit, it will probably take a very long time, but someone can sit and do that computation on pencil and paper.
I don't think so. I believe that.
Why not? So you're saying there's something magical in the human architecture that can't be describe.
One of the things I stick to is that there is no magic.
So what is it then that makes it impossible to do pencil and paper for the human version?
I think
Other than that, we haven't decoded it yet.
I believe that in every brain cell of the human body, probably every brain cell, but at least every pyramidal cell, it is acting like a quantum computer. And
Okay, so you believe in the Hammer-off
exactly.
Penrose
Yes.
microtubular theory. Okay, but what if that's disproven? Then you think it's possible?
I still believe that there's some other quantum state being considered. Even if their theory is wrong, it's some other thing. And I believe that it's not something that can be reduced to computational things. It is
What about emergence, though? What if there's something that it's some piece of architecture that we just haven't implemented that creates some emergent phenomenon by default of having those pieces in the cauldron, so to speak? Because, I mean, I don't think people even know what consciousness is. I don't think there's a real test for that. Not that I know.
That is true. That is true.
But I'm not even arguing for consciousness here, right?
Yeah.
I'm arguing for knowing and saying that, hey, if we define human knowing in a certain way, does knowing require consciousness? Or can you know things without being conscious?
So
I think it helps to be conscious.
Like every word, we can make that word mean whatever we want. So like we changed the definition of planet a few years ago. They're just words. So is it useful to have a word knowing that's only for consciousnesses?
Why is it so important to know that it knows something? I mean, look, I started this by making that comment on Ali's thing and saying, hey, it doesn't actually know anything. But if it assume it had actually given the right architecture, right? And maybe in a few years or maybe in a year, GPT-5 will give the correct architecture when you ask it that.
Is it possible that the question was posed? I'm sorry to interrupt you, but is it possible that the question was posed in such a way that it tricked it? And because
maybe
it could be, yeah. So exactly, with a little clever prompt engineering, I'm sure we could get it to, instead of using DALL-E to generate an image, it actually just fetches the right diagram from the billions of articles it has read, and it's like, yeah, here's a just like Google does, right? Google, if you ask Google the same question, it will actually give you the correct architecture, right? It's not going to hallucinate. It's not generative. It's just going to fetch the right.
Because it's not generative, because that answer is ultimately coming from somebody who reasoned their way through that, right? And
yeah,
put it on
but Google is not reasoning, right?
Google's not.
Someone did the reasoning for Google at some point.
You know, one point you made a minute ago, though, it doesn't match up with life or living things. And the point you made was, if you get the prompt right, eventually it will give you the right answer. But life is all about getting the right answer, no matter what the external environment presents you with. Michael Levin, I love watching his videos. He talks about how life at every scale is trying to achieve a goal, no matter, even if it's perturbed.
But through trial and error, right? I mean, even humans do it at our complexity level. We don't always get it right. But if we get a second chance, like in a marriage with a partner, like you might not get it right the first time, but if you get second, third, fourth, maybe fifth time, you will eventually, even though the question or the request is ill-posed, you will get it right. But probably not the first time.
I think a lot of life is competing for scarce resources. And I always think of life as just a giant distributed system. And if you think about, you were talking about Stephen Wolfram from before, how at each time step, I don't remember exactly how you said it, but there was like some computation. But if you think about that, maybe from an Einstein perspective with relativity, you could think of it as being an infinite amount of time steps, maybe not, obviously not literally infinite, but somehow all of those times consolidated each moment into some measurement that we can all agree on, at least to some degree. But I think maybe that's what human brains to some level do is they can just extract out all that information into something meaningful, without having that information overload. If that makes any sense.
Like,
To avoid information overload, we're back to discretizing a continuous world.
so are we saying, are you guys saying that there is no way of actually testing that someone knows something?
No, there is a way.
What's
I
the-
think there is.
Yeah.
What's the
I
way?
think. Well, I mean, okay, we talk about, let's go back to the president example. I think
Mhm.
if you just had the one question, what is a president? I don't think that'd be sufficient to test that you know something. I think you have to
Right.
attack it from as many different angles as you can, the same concept from many different angles. Ask different questions about what it means to be under the authority of a president.
Don't you think that a lot of that ChatGPT, even as it is today, would be able to answer? I mean, look, the transformer question, if you ask that from, a high school student, and they say, well, I don't know, which is probably what maybe ChatGPT should have said, or Dolly. But then you tell it, well, you've probably seen architectures where just try your best to draw it. But I don't know. Just try. It doesn't matter. I'm not gonna punish you. Just try to draw to the best of your ability what you think from what you've heard, what a transformer looks like. They would probably produce something like that. Probably not as good, actually.
Yeah, not as good. I wouldn't do it as good.
No.
But I'm not sure what I'm even looking at that picture. I'm not even sure what that is.
But my point is, like what you're about, you started to describe as a test to test that human. Couldn't ChatGPT pass that? Either today already or tomorrow.
I think there has to be an element of action with the knowledge. Now, I hope I'm not stepping out of the frame of the question here by saying that, but I really do think without an ability to act on something, that knowledge is almost like clouds. It's just floating above, something you're unable to, like if you can't act, that's the whole point of acquiring knowledge, is so you can use it. And just reciting it is almost pointless.
I like that. I like.
Yeah. Okay. You're making me think all kinds of neat thoughts here. Let me try to jump into this. When I first learned about quantum states, and that when you measure them, you're ruining something. You're taking something that was pluripotent and forcing it to choose one thing. So it was this manifold complexity, and you force it into a bunch of binary states. Like it has to be this and it has to be this. And it felt like the universe had a little door, and behind the door was something fragile, something beautiful, something wonderful. And you can't look at it. You're not allowed to. And in fact, when you do look at it, it disappears into nothing. It evaporates like mist. That's what it felt like when I first learned about this. Now, what we're talking about, I think, is akin to saying, how do we tell if that integrated, beautiful, delicate state really does exist behind that door for AI versus just humans? How will we know? Well, we only know by what we see when you open the door. Now, when you open the door for a human, that complex, beautiful state whittles down to, just a few things that we say out of our mouths or actions that we take with our macro scale, muscles. So that whole world, the world of words, the world of actions, is a world of observation. And observation means the quantum state is gone now. It has been collapsed into something, just by very definition. So how do you know if those observations were initiated by that beautiful, pluripotent, delicate state, or if it was just the actions and there was nothing like a consciousness behind it. And I think we may never know, except there is a crazy story I heard recently that made me think this can't be true, but it would make a cool story. So I'll tell it to you. This friend of mine spent, many years very close to his father, and his father had ailing health, but he spent so much time with him. He had this idea that part of his mind was entangled with his father's, like quantum entanglement, but at a body to body level. Like there's so many entangled particles. Maybe it happened through the eyes, who knows? But there's so many entangled particles that he was going to go visit his father one day, but they stopped at a friend's house on the way, and that friend came out and he knew before she even said something, my father's died, hasn't he? Somehow he could feel it. Like the other end of those quantum entanglements, that end collapsed, and he was able to feel that on his end. Another story, which happened to a friend of his, and this one's even crazier. He was friends with two identical twins, which means they started out as the same fertilized cell, right? And they split and then developed into different, humans that then grew up. At one point, probably in his 30s, one of them was on his way somewhere with his wife. His left arm goes limp, and he has trouble feeling it. He can't move it. And he's like, "What's going on?" And they thought it was a medical emergency. After about a half an hour or 45 minutes, it started to totally come back, and he was okay. And then he gets the call. His twin brother was just in a bicycle accident. His left arm has gotten mangled. Is that because there's some entanglement that maybe started in the egg? I don't know. I mean, I don't think so, because I think entanglement is such a delicate thing that typically at body temperatures it only lasts a few nanoseconds. But
yeah, which is also my theory about that, why I have difficulty with microtubule theory. But I mean, for me, the quantum argument still doesn't solve the problem, because it becomes a little bit like the God argument, where it's actually worse than the God argument, because God, at least you could argue whether it exists or not, has some sort of free will or will.
I've heard the argument that it doesn't, but
right. Well, the quantum argument, it kind of just defers it to what we think. Now there's alternatives to that argument. There's the Bohm hidden variable approach.
Yeah.
Is, in my opinion, much more appealing. But anyway, the quantum argument kind of just defers it to what we believe is true randomness, because otherwise true randomness doesn't exist in nature. But the true randomness of wherever these real random variables actually come from, and it's kind of end of argument there. It's like, well, okay, free will exists because there's such a thing as this real randomness that comes from quantum states, and that's sort of what maps to. But it still doesn't explain where's the free will then? Like, what's the connection between the metaphysical and the physical? Where does that connection happen? And who or what is actually making the decision then? If it's just a quantum state that's collapsing, what's the determinant that makes it collapse in a certain direction or not?
It's the rest of the entangled state pulling on it.
Well, I think it's almost like if you look at Super Mario Brothers, the video game, and you look at it from a purely physical perspective, it's almost meaningless. It's like a computational system, I guess, but you look at it from the perspective of a human, and there's a whole world in there. So there's like many ways of looking at it, and that's kind of more how I see quantum physics is there's just many different ways of observing the same thing, I guess. But for what you were saying about the dad story. What are weren't there like three assumptions of quantum physics? Like there was non-locality, uh, freedom of measurement, and something else. I forget what the other one was, but one of them has to be violated, I think.
Yeah, they're talking about
And
the Bell
have you heard of
formula.
Sabina Hassenfelder?
Yep,
Yeah.
and I love her. We both love her.
And she seems to think that the freedom of measurement is something that is I think violated constantly. So you can't freely measure anything, which means that the world is super deterministic. Which I mean, I think that means that ultimately you have no free will. Um,
I agree.
I
but
disagree.
but
So
I
here,
think
I think Leonard
there's always going to be a
Susskind.
disconnect. What? Sorry, Graham.
Have you heard Leonard Suskind's resolution of that? Leonard
I don't
Susskind.
think so.
Okay,
The
I love
proposed resolution.
his resolution for this conundrum. Makes perfect sense to me. He believes that locality is not violated, even with what we call the non-locality effect, because every pair of entangled particles creates a
Oh, yeah. Well, that is just mind-boggling. It's hard to fathom that. Just for me, it's like, wow, that just would be so crazy if that's the case.
yeah, exactly that, Babak.
ER equals EPR. Yeah. The
Oh, the Einstein, Rosen, Podolsky, or whatever.
Podolsky. So yeah, he proposes this bridge. Um, yeah, but basically entanglement. He tries to shoot two birds with one stone, basically explaining, black holes and white holes, and entanglements in one go.
Oh, I love it. To me, it smells right.
Yeah, I mean, yeah, it's just it needs to be proven. Like
Well,
everything.
I've heard Sabina Hassenfelder equate that to, the Star Trek teleportation as you wouldn't literally be able to transport conglomerates of matter that way, but you could teleport information, so to speak, that way.
Right.
Which you get into what information really is. There has to be a difference between information and matter. And so,
Yeah, but there's all these theories that equate information to energy, and we already know energy and matter are equivalent.
they're equivalent. They're not this.
But they're
Well,
not the same. Yeah, so maybe there's I'm trying to remember the scientist's name. He's at MIT, I believe. Who has a much more sophisticated theory around this, where matter is basically energy plus information. That you can't, yeah.
No, that makes sense.
When you convert between one to the other, you need this extra piece, which is information.
Is that because matter is discrete, and the only way, and because it's discrete, you can get information from it, whereas energy is more. I don't even know if that makes sense.
Yeah, that's an interesting thought.
Huh. Oh, that's that's good. That's good.
I'm not sure if that. I'm not a physicist. I just love to read that stuff, so I'm not sure if what I'm saying makes any sense at all. But
well, actually, energy is quantized.
Yeah, both matter and energy are quantized, right?
Yeah.
And I'm not even that sure about matter.
But here's a question. The amount of energy, kinetic energy, that a particle has when it's coming at you it's related to the velocity squared. Now that kind of energy, we could think about it as continuous, because if you're moving a little faster toward it, then you will view that as having a little bit more energy. Is that quantized too? I don't know. Or is it only when energy flows from one thing to another that it's quantized?
It's a good question. Maybe when you measure it, it's quantized, but before that point, you could just.
Yeah.
I think it has to do a lot with measurement, or rather maybe with transition, like energy transitions from one state to another. When during the transition, it's not quantized, but once it reaches a new state, it's quantized. But let me just take a step back here. What would I'm trying to backtrack how we got here.
We've got there's
No, but this is what's the beauty of these podcasts. We go into many different rabbit holes. It's almost like a ant.
I love it.
What do you call it? Ant colony, where there's many different rabbit holes in many different directions. But if I backtrack through the rabbit holes maze, just to bring it to the point of where, whether it's free will or not, and whether or not that has to do with the constituency of information within those quantum states or not, it still begs the question of I feel like we're making a lot of connections here between free will, consciousness. So it's kind of like free will. There's no free will without conscious will, and knowing. Like so conscious. There's certainly some sort of relationship between consciousness and knowing. I don't know if it's necessary or if it's just is it sufficient and necessary, or is it just sufficient? But there's a relationship, I don't deny that, between consciousness and knowing, and certainly between consciousness and will or free will. What I'm hearing, you're certainly saying it in different ways, but what I'm hearing from both of you is that there can't be real knowing without consciousness, and there can't really be anything that we call consciousness without free will.
But my problem with that is if you have an AI system and you try to prove it based on that assumption, someone might just build another transformer that can act as the self-reflection model and then say, oh, well, it knows things because it can somehow reflect on the original transformer's outputs.
Yeah,
and I don't think that's...
My argument then is that we got to either admit and say that this transformer or this AI system is conscious, or at least it knows things the way humans know things, or we got to say that humans don't know anything and humans aren't actually you can take it as far as saying humans don't actually have free will. But maybe you even can argue, like the argument can be taken as far as saying humans are not conscious, or don't have consciousness. And I that's when I start having a problem with it, because I actually believe consciousness is a real thing and humans do have it. I'm not part of the camp of these scientists who claim that consciousness, like what's his name?
Yes, I know who you're talking about. The hallucination. It's
that it's a hallucination. It's not actually real.
What is his name? I forget his name. But
the bearded guy. Well, he's one of many.
No, I'm thinking of the bald guy who gave a TED talk on it.
I'm thinking of Dennett.
Daniel Dennett?
Yeah, Daniel Dennett says that. But I think I know who you're thinking of as well.
He's a British guy, I think.
Yes. Graham probably knows.
Forget his name.
I know Graham is on the same camp as us. He actually believes consciousness is a real thing and it needs to be explained.
I think I'll give you my take. I think it could be a hallucination, and I can think it's a real thing all I want. Just like a religious person can think there's a God all they want, and you can't really prove that, right? I don't think you can. So I think there are things in the realm of philosophy that are just useful to think whether or not they might be true.
Okay, I'm trying to look up a certain experiment that gets at this.
At the consciousness problem?
Yes, and something else.
Huh. Some of those neuroscience experiments are just kind of unsettling. Couldn't point to any specifically, but just some like neurological disorders that some people have.
Okay, there's an experiment I'm trying to look up, and I haven't been able to remind myself where it is yet. But if you think about the experiments on non-locality, some similar kind of thinking is going to help us disambiguate rote actions from conscious actions, deterministic from non-deterministic.
Wait, say that rogue actions?
Rote, like rote, R-O-T-E.
Oh,
So let's say autonomous or something with agency, something without. And I think it's going to be a similar kind of thinking to the way they look at non-locality. So consider this: if you have a briefcase that has one glove in it and another briefcase that has the other half of a glove pair, one's going to be the right hand, one's going to be the left hand. And you send one of them to the North Pole and one to the South Pole, and then you open one of them. And instantly, the person who opens that one knows the other one as well. And at first, that was our model for non-locality, for having, two electrons, or let's say two photons. You take a laser, you shine it at a parametric down conversion crystal. What it does is it splits it into two beams of photons, where every photon that came in was literally split into two photons having half the energy. And for those two photons, one is going to have clockwise polarization, the other one's going to have counterclockwise. Now, which is which? Well, when you measure over here on one of them, and if that photon has counterclockwise, then you know for a fact that its entangled partner has the other way. Is that decided ahead of time, like when they're splitting, or is it decided where they meet? Another way you could do, polarization this way versus this way. And they've come up with some very nuanced experiments that incorporate double-sided mirrors. So think about a mirror that reflects half of the photons and lets the other half go through, okay? And then they hit other mirrors that are 100% mirrors, and then they hit another double-sided or halfway mirror. And there's some filters in between that filter out the ones that are polarized one way versus another way. And they've come up with a very unique or very nuanced set of mirror configurations, such that, going back now to the gloves, let's say that we were able to show without a doubt that the handedness of the gloves was not decided until they were opened at the North and South Pole. And we can do this by showing the behavior of the probabilities of what happens when you open them, when you open the suitcases. You do hundreds of thousands or millions. I mean, they do this on billions of photons, really. And they look at the probabilities across possible futures. And they can show that, okay, if the glove has been decided before you make the trip to the poles, then the probabilities in the future will work this way. If it's not decided, then they'll work this other way. And then they show that it's that other way. So we know that.
I mean, again, unless the underlying theory or explanation model is something completely different, like the hidden variable model of Bohm.
Yeah, that's true. Unless there's some totally new theory that also explains the facts. So we can either stick with our one theory that we already have that explains the facts, or come up with some other new theory that also explains those facts. You always have to leave room for that. But the idea is that maybe it's not decided until someone opens it. Any last thoughts, you guys?
John, I think as the guest, you should get the closing remarks or thoughts.
I can't help but think that that in terms of humans and in terms of the quantum realm and in terms of, you know, what it means to be a human, there's always going to be, to some degree, a difference with our experience that just comes from being a person, you know, and I don't think you can necessarily recreate that in the same way. Now, you might be able to recreate the same knowledge, but I don't think you can recreate the same experience. You can try, right? But I don't think it will be the same thing. There are just things that are, you know, naturally human-esque that I don't think we can replicate. And I also think that there's maybe, it's hard to map quantum theory onto our day-to-day lives. I mean, I always think there's just going to be part of the best thing about being a person is creativity and almost being able to make things up and act as if they're real. And I think you could argue that that's a lot of what we do throughout the day, but we can all agree on it. That's why we think it's reality. I think that might be unsettling. I don't usually bring that up in the office. When someone asks for an invoice number, I don't say, well, you know, you just really made that up at the end of the day, but I'll bring it to you anyways. But yeah, I guess the last thing, I guess the point I'll leave it on is, I think, again, knowledge without an ability to at least act on your environment and understand the consequences of that is somewhat useless. So yeah, that's my rambling on there. But I really appreciate the opportunity to be here. This is, you know, I love conversations like these. So
This is one of my favorites so far. Thank you for being with us, John.
Likewise, John.
Thank you both. Well, you know, let's do it again sometime. If you both would like.
Definitely. Always happy to have you as a guest again.
All right. Well, y'all have a good rest of your evening.